Okay, moving to page 198 in our 7-1 notes. The very first thing we have, you guys, is a corollary. Remember, a corollary just follows a theorem. And this is stating that all quadrilaterals, when n is 4, we've got 360 degrees for all of those. Now, the reason this is important is because the group of quadrilaterals comes up, and there's things about quadrilaterals, specifically four-sided figures, that we're going to learn about. And so this 360 idea just needs to be at the forefront of your mind. This is all about inside of a triangle. Inside of a triangle, when I go down here to this Polygon exterior angles theorem, I want you guys to shade in the inside. And I'm having you shade this in because I want you to just maintain the focus on, if you notice, I've just got this shaded. The numbers are all on the outside. You don't have that page? Is there anybody that doesn't have that page 198? There were some packets that didn't have it. Here you go. Okay. Now, again, I shaded the inside, and I want you guys, this is exterior. And this exterior angles theorem, I want you to notice here that this is a 5-sided figure. But this exterior angles theorem, having a sum of 360 degrees, applies to every single type of polygon. What's up? Yeah. I want you guys to come over here, and let's draw a triangle. I'm going to kind of draw it upside down. Let's draw a 3-sided figure. Now, we got to get a real beat on what the heck is going on with these arrows and these exterior angles, because it's kind of weird. Go ahead. It's kind of weird how they use the arrows through here to show the different angles. Now, this 5-sided figure, you guys see there's 5 exterior angles. Let's go over to this triangle, and you might want to watch me first. It's kind of, do you guys notice that these arrows are just going around in a circular pattern? Think about our 360 degrees. You know, they've taken and said, let's extend this side out, that's angle 1. Extend the next side out, that's angle 2. Extend the next side, that's 3. And they finish that pattern all the way around. Let's do that on this triangle. I'm going to shade it in. And I'm going to take this side I have over here on the left, and I'm going to extend it out, and I'm going to call that my exterior angle 1. Then I'm going to go over here. Notice I'm going to work around, I'm going to work clockwise around this. When I do this one, I'm at angle 2. When I extend this third side, there's my angle 3. The sum of the exterior angles in a 5-sided polygon is 360. The sum of the exterior angles in a triangle is also 360. Let's draw one last one. Let's put a looking maybe like a trapezoid, 4-sided figure, kind of like a trapezoid. And again, the idea of going around in a circle, I'm going to extend this side here. Take a look up. I'm going to put a 1 there. And then we're going to work clockwise around our trapezoid. Extend the next side. Put a 2 there. Extend the next side, moving around with a 3. Extend the next side, that would be our 4th. So what are those 1, 2, 3, 4 angles, or what are they going to add to? They always do. All the way around the outside, no matter how many sides you have, they add to 360. No matter how many sides you have, when we're talking exterior angles, they add to 360. So we really need to make a big separation between that interior idea of n minus 2 to the triangles that fit inside. That was all the first page. We need to separate that from exterior angles theorem. Every single polygon has a sum of 360 for exteriors. All polygons, exteriors, add to 360. This is all about exteriors. Interiors on the other page is a whole different ball game. Now, there's not a whole lot of practice with these types of problems in our notes packet, and so I wanted to give you an example of the way that things would be, like some example problems of how this would be used. First of all, I want to, in my examples, I want to give you guys the directions to find the measure of each. This is where it's going to get tricky. Each exterior angle in a regular. Now, you guys remember regular means same, all the sides are the same and all the angles inside are the same? If I've got a regular pentagon, what's the sum of the exterior angles in a pentagon? It was the one that we were given, 360. If they want us to do each exterior angle, we'd have to do 360 divided by 5. Each of those exterior angles, because all the sides and angles are the same, each exterior angle would be 72. 360. Now with, let's put a, how about a square? Square is a regular polygon. How many sides does it have? What's 360 divided by 4? All those exterior angles would be 90. It doesn't matter how many sides I have. I'm going to go and show you guys that notation like an 18-gon. What's going to be the sum of the exterior angles for something with 18 sides? 360s always. 360 divided by 18. I don't have a calculator handy. $20? Those would each be 20 degrees. You guys see how it changes? Let's throw one more on here, an 11-gon. 11 sides. This is probably going to be a decimal. It could happen. I think that's why I wanted to put it in our notes. If it has 11 sides, we're still doing 360. This is exterior angles. We always go back to 360.
I don't understand where you find that.
So we're going with the rule that every time we're on the exterior of a figure, the sum of the angles is 360 degrees, and I'm just showing you right here. So this rule is what we're given to use. And I'm showing you right here how problems like this are going to come up. You know, like if it's regular, you've got to find the measure of each exterior angle. That's going to be one that you've got to watch for these. That type of problem is going to come up. I actually took this kind of to a more advanced level than what's even in the extra practice. When you're ready to go on, let's turn over to the extra practice.